Alright, again, we're going to be going through those steps of greatest common factor, looking for different squares, trinomials. As you look at this problem, it has no greatest common factor. There's no term that 81 and 121 share in common, but it is a binomial, so there's a chance that it's a difference of squares, which it happens to be, because 9 times 9 is 81 and 11 times 11 is 121. So we're going to break this down into 9n times the 9n and 11 times 11. That will give me my zero term because I'll get a 99 and a negative 99 as long as I put a positive, a negative, and a positive inside the parentheses. Okay, so as a reminder, this is what I keep talking about every time, looking for the GCF and then looking at what's left over. If there's no GCF, then we're going to start with those parentheses. So on this next problem, we're going to look for that greatest common factor. There is a greatest common factor of 5x. 5x times x squared is 5x squared, minus 5x times 4 is 20x. Now this is not finished because inside the parentheses, if I look carefully, this binomial is a difference of squares. X times x is x squared. 2 times 2 is 4. I can get the zero term by having a negative and a positive, negative 2x and a positive 2x. Next problem, look for your greatest common factor. Greatest common factor is 3. 3 times u squared is u squared, minus 3 times 9 is 27. 3 stays out front. This is another difference of squares. U times u, 3 times 3. The way I get that zero term is with a minus and a plus. Just have a few more slides. Looking at this next one, look for the greatest common factor. 2 would be the biggest number that can come out of all these, and there's an x they all share in common. So 2x times x squared is 2x cubed. 2x minus 16x is 32x squared. 2x times 64 is 128. Bring down your 2x and then break up your trinomial into two binomials. X times x gives you x squared. There's lots of factors of 64, but I always like to try the square part first. This gives me 8, and 8 is exactly what I need because I need a 16. It actually is a negative 16, so I need a minus and a minus. I could simplify this, and I will, by writing it as 2x, parenthesis, x minus 8 squared. So this is read as 2x times the quantity, 8 minus x squared. Two more examples. Greatest common factor here is 3n. That leaves me with an n squared. 3n times n squared is 3n squared. 3n times 10n is 30n squared. And 3n times 25 is 75n squared. Bring down my 3n. Break up my trinomial. N times n. Again, I'm going to try that squared part first. And sure enough, that's what I needed. 5n and 5n. I want a negative 10, so a negative and a negative. Minus and a minus. Bring down your 3n, and I can write this as n minus 5 quantity squared. Last problem. Greatest common factor happens to be 2, and it's a w squared they all share in common. So 2w squared plus 2 times 5w gives me the 10w cubed. 2 times 3 gives me the negative 6w squared. Bring down my 2w squared. The only way I can get 2w squared is with a 2w and a w. The only way I can get 3 is with a 3 and a 1. So if I put a 3 and a 1 here, that does give me a 5. However, I can't make them both be positives because then I will end up with a negative here. So I actually need to flip-flop these around. And that will give me 6w and a 1w. I want a positive 5w, so a minus here and a plus there. That would be the correct answer.